Hey, welcome. We're starting with Unit 6. We're going to start sketching our sine and cosine graphs. But before we start sketching our sine and cosine and start doing transformations on it, I want to talk about the actual shape of the sine function. For that, I have unit circle in front of me, which kind of lists all the sine values, as you're aware, which is what we learned in last unit. All the y values here are representing the sine values of a particular angle. If I go about going around the circle. So those are the y values. However, the angles listed here are given in radians here and then in degrees here. So if I were to sketch graph of sine on the x-axis, which is the domain, we will list all the angles, and that has been already done for us on the grid. Notice we start at 0 and we end at 2 pi, which takes care of one full rotation. Against the x-axis, we're now going to plot the y values of sine function, which is going to come from here. So when sine is or the angle is 0, so sine of 0, the value is 0, which is here's the input and here's the output. For the next one, sine of pi over 6, as we know, is half, which means here's the input in radians, angles, and here's the output. So let's start plotting some of these. 0, 0 would be a point right here. For pi over 6, the output is half. For pi over 4, which is 45-degree angle, the output is root 2 over 2. The approximate decimal value for that is 0.866-ish, which means that takes me about here, because we're going up in 0.2, so that's 0.2, 0.4. At pi over 2, which is right here, sine reaches its maximum value 1. That's a plot right there, point right there. At 2 pi over 3, the value is back to 0.866. As you can start seeing, it's pretty symmetrical. Then comes in at 5 pi over 6, the value is half, right there. By the time we have completed half a revolution, sine of pi is 0, so we're back here at 0. So that takes care of the first two quadrants. And if I continue in the same fashion, sine of 7 pi over 6 is negative half, which is right there. Sine of 4 pi over 3 is negative 0.8666. Sine 3 pi over 2 is negative 1. And as you can guess, the rest of it is pretty symmetrical. Which means if I try to connect all this, this is not a straight line, however, it's a nice little curve, basically a wave. And that completes one cycle of sine. That is the basic shape of one cycle of sine. I call it like half a mountain and then half a valley. But do know this continues forever. But technically this goes on forever in each direction. So it's a wave that continues from forever to forever, depending on the domain restrictions. If I just look at one cycle, the domain of one cycle would be 0 to 2 pi, because we are here at 0 and goes all the way to 2 pi, both of them being inclusive. Range, as you can see, the minimum it hits is -1, the maximum it hits is 1, both inclusive. Domain of the full wave would be all real numbers, because there are no breaks, no holes, no asymptotes. Range of the full wave does not change, it still stays as -1 to 1. X-intercepts, from that one cycle that we can see 3 x-intercepts, 0, 0, pi, comma 0, and then 2 pi, comma 0. However, there are infinite number of x-intercepts in the full cycle. There's a pattern to it. The x-intercepts occur at every multiple of pi in either direction. So for now, I can put 2 dots on each side. However, there could be a formula written for that. Y-intercept, we only see 1 because sine crosses y-axis only at 1 point. Maximum value is 1, and that occurs at pi over 2. So the point would be pi over 2, comma 1. And the minimum value is -1, that occurs at 3 pi over 2. And the reference point for that would be 3 pi over 2, comma -1. Let me fix this. Okay. Then comes in some basic things that are associated with a wave. Because this is a wave, a little bit of physics come into it as well. This right here is referred to as the midline. midline of the wave. And the height of the wave above the midline is what is referred to as the amplitude of the wave. So in this case, as you can see from the midline, goes up to 1, and that is referred to as the amplitude. B, which is period constant, a better name or another name for that could also be frequency. I am graphing f of x equals sine theta. Frequency is given by a number that sits between the sine and its input. In this case, frequency is 1. Phase shift is referred to as the horizontal shift, but because this is a parent function, there is no phase shift associated with it. Vertical shift is the vertical up or down motion of the wave, but because the midline is sitting at 0, for parent function, there is no vertical shift either. Period is referred to as the time, you can say, that it takes to complete one cycle. So this refers to as the period of this wave. In this case, for parent, the period is 2 pi because it starts to repeat itself after every 2 pi. Interval we're going to use for sketching purposes. What we do is we take the period, let me write period here, and all we do is split it into 4 parts, one for each quadrant. So in this case, it's 2 pi divided by 4, which is pi over 2. So this automatically refers each quadrant. In this case, you can see each quadrant is represented by 90 degrees or pi over 2, which is normal for parent function, which is what parent function is representative of. So these are some basic characteristics of the sine graph and the parent function. Now we shall start doing transformations on it, which is when the amplitude and the period and the phase shifts and the vertical shifts can vary. Let me also go ahead and sketch cosine graphs so you have understanding of the basic shapes of both the functions. We're going to do exactly similar stuff. To be able to sketch a function, we need input values and output values. Because we're sketching cosine theta or cosine x, actually I should write x here. We will take our inputs as our angles and radians, but our output in this case will be the cosine value, which are the ones listed in blue. So for cosine of 0 is 1. So our point would be 0, 1. Cosine of pi over 6 would be root 3 over 2. So our point will be pi over 6, root 3 over 2. Root 3 over 2, decimal value, let me quickly get that. Root 3. I'm just going to quickly get that for you. Square root of 3 divided by 2. And that value is 0.866, which we did earlier, so that would be 0.866. Let's start sketching them. For 0, cosine value is 1. For pi over 6, 0.8666. For pi over 3, cosine is half, right here. Pi over 2, cosine reaches 0. 2 pi over 3, cosine reaches negative half. 3 pi over 4, cosine is at root 2 over 2. Let's see the value of this. Root 2 divided by 2 is 0.707. So about here. Pi, cosine is negative 1. And then it starts to repeat itself in either direction. 0.7. 3 pi over 2 is back to being 0. There, and by the time we come back to 2 pi, cosine value is back to 1. And when we connect this, you can see this is also not a straight line. It's a nice wave, slightly off by that point, but you get the general idea. There we go. Also note this also continues in either direction. I only graphed one cycle, which basically means I only graphed one rotation. So unless there is a domain restriction, this goes on forever in both directions like this. So once sketched from negative infinity to infinity, both sine and cosine look the same. They're slightly horizontally shifted versions of each other. Otherwise, they're very, very similar. Now, when you look at one cycle's domain, as you can see, it goes from 0 to 2 pi, both inclusive, which is the same as sine. Range of one cycle is negative 1 to 1, the lowest to highest. Domain of full wave, just like sine, would be all real numbers. Range of the full wave will not change. X-intercepts vary. The first x-intercept I see is at pi over 2, comma 0. The next we see is at 3 pi over 2, comma 0. We only see two of them, but in the full cycle of cosine, there are infinite number of x-intercepts. Y-intercept, there's only one, 0, comma 1. The maximum it reaches is at 1 also, which is at 0 radians. And then it reaches again 1 at 2 pi, but it continues to do that over its entire cycle. The minimum value is negative 1, which it reaches at half its cycle at pi. Same idea applies. This is referred to as the midline, and the height of the wave above the midline or below the midline is referred to as the amplitude. So the amplitude of cosine wave is also 1. B sits right here. The number there is 1, which is referred to as the frequency or period. And as I start sketching transformations, I'll explain more about periods, period constant. Phase shift is none because this is the parent function. There's no vertical shift either because it's the parent function. Period, same definition, 2 pi over b because b is 1. Period stays as 2 pi, which is the same as sine. The time it takes to complete one cycle is referred to as the period. So 2 pi also. Interval, like I said, is we take the period, split it into 4 parts, referring to each quadrant. And we will put this to use when we sketch transformations. So here is some basic idea of the cosine function, its attributes, including domain range, and also how the wave behaves for his transformations. In the next video, let's start sketching sine and cosine graphs along with transformations. See you then.